Okay, let's be real for a second. Have you ever looked at a massive IPv6 address and just felt a sudden wave of panic? Yeah, you're absolutely not alone. Today, in this explainer, we are unlocking the ultimate cheat codes for implementing IPv6 on Cisco routers. It is time to finally tame this 128-bit beast.
I mean, just look at the sheer scale of what we're dealing with here. The old standard, IPv4, gave us about 4 billion addresses, which sounded like a lot back in the day. But IPv6? It gives us 340 undecillion addresses. That is literally enough IP addresses to assign one to every single grain of sand on planet Earth. And honestly, we'd still have a ton left over.
But this immediately brings up a pretty terrifying question, right? With an address space this incredibly massive, how do we actually configure a physical router to handle them without completely losing our minds typing them all in? Section 1. The Great Address Shortage. Think of IP routing kind of like the global postal system. To deliver a package, you absolutely need a unique address. Well, back in 2015, we essentially ran out of unique IPv4 addresses. We spent the whole 1990s creating these short-term band-aids like NAT to hide multiple devices behind one single address. But eventually, we just needed a much bigger neighborhood. So the architects of the internet bumped us up from a 32-bit space to a massive 128-bit space. But this creates our very first puzzle. How on earth do you deal with typing these monstrosities? We went from a nice short 4-part number to this giant clunky string of hex digits. One tiny typo, and your router is just sending packets straight into the digital void. Section 2. Taming the 128-bit beast. Fortunately, you actually don't have to type the whole thing out. The rules here are surprisingly simple. First, you just drop any leading zeros in any quartet. So 0-100 simply becomes 100. Second, you find the longest continuous string of all 0 quartets and replace them with a double colon. And boom, that massive 128-bit beast suddenly collapses down into something you can actually read and, more importantly, type. Okay, so we abbreviated the address into a much more elegant format, which is great. But wait, even with those abbreviations, how do we physically assign these addresses to our hardware when we're, say, building out a massive enterprise network? Section 3. Configuring routers step by step. Think of these server racks as the local post offices of our internet. This is where the magic actually happens. A router receives an IPv6 packet, checks its destination, consults the routing table, and then blasts it out a completely different physical wire to get it closer to its target. Now, here is a massive gotcha for network engineers. Unlike IPv4, which pretty much routes right out of the box, IPv6 routing is actually turned off by default on Cisco routers. You absolutely positively must use the global IPv6 Unicast routing command first. If you skip this, your router basically just acts like a very expensive desktop computer. Only after typing that do you jump into configuring the interface itself. Sure, we can manually type out that static 128-bit address. But hang on, if you're configuring, 50 routers across an enterprise, wouldn't it be way more efficient if the router just figured out its own address on the fly?
Section 4. The EUI64 cheat code.
Here's a brilliant trick. Every router interface already has a permanent, globally unique hardware fingerprint, its 48-bit MAC address. Using what's called the EUI64 cheat code, we just chop that MAC address in half, smash the hex digits FFFE right into the middle to stretch it out to 64 bits, and then flip the 7th bit. And boom, you just automatically generated a unique interface ID without typing a single address digit yourself. And it gets better. We can take that automation even further with Slack, that stateless address auto-configuration. If you combine that EUI64 trick with Slack, the router can actually act like a regular host device. It automatically requests the network prefix from your ISP, and the second it receives it, it calculates its own full global address. Literally 0 manual hex typing required. How cool is that? So we figured out how to automate public global unicast addresses, the ones that reach the wider internet. But wait, what if a direct point-to-point WAN link between two of our internal routers doesn't even need a global address to function? Why waste the address space, right? Section 5, the secret router addresses. Well, if you just type the simple IPv6 enable commands on an interface, the router skips generating a public global address entirely. Instead, it generates a private link local address starting with FE80. And the crazy thing is, this FE80 address is literally all a router needs to route packets to its immediate neighbor on that specific wire. The fact is, routers rely heavily on these special local scope addresses behind the scenes. They use those link local FE80 addresses as their next hop destinations, and they use special multicast addresses like FF022C to automatically discover other IPv6 routers, or FF025 to run dynamic routing protocols like OSPF. They're basically just whispering to each other in the background on these reserved channels. But wait, there's a slight catch here. IPv6 completely eliminates old-school IPv4 network broadcasts. There's no longer a way to just yell at every single device on the network all at once. So, how exactly does a router find a specific neighbor's MAC address if it can't broadcast? It uses a wonderfully targeted solution called a solicited node multicast address. Instead of yelling at everyone, the router calculates a special multicast address using a standard prefix combined with the last 6 hex digits of the target's unicast address. By pinging this specific hybrid address, it only bothers the tiny handful of devices that share that exact ending. It keeps the network traffic incredibly quiet and super efficient. So, how does all this come together? Well, once we apply these configurations on the rack and run the show IPv6 route command, we actually see the router automatically populating its own routing table. It dynamically creates connected routes for subnets and local host routes pointing right back to its own interfaces. It all happens the very moment those interfaces come online. Depending on your specific needs, you now have a complete toolkit at your disposal. You can manually dictate a static address if you want total control. You can automate the host portion with the EUI64 cheat code. Or for private connections between routers, you can rely entirely on those link local FE80 addresses. It just gives you total flexibility. So, now that you possess the cheat codes for teaming the 128-bit beast, I want to leave you with this to ponder. If IPv6 allows devices to automatically generate their own addresses, locate their neighbors without broadcasting, and basically pull routing prefixes right out of thin air, what will the daily life of a network engineer look like when IP4 is finally turned off for good? Are we configuring networks, or are we just watching them configure themselves? Keep exploring, and I'll catch you in the next explainer.